welcome everyone to this week's DeSci Labs product community call. Thanks everyone for joining. It's been a very eventful week with DeSci Boston and the ACM conference and SmartCon coming up. So always an exciting time. We are now back to regularly scheduled programming after our break last week. So excited to see everyone back on the call again today. I'll go ahead and give a couple quick updates, and then I will pass it off to Chris to talk more. And Chris, I guess in the background, if it's possible, would you mind getting the demo pulled up that was showcased in DeSci Boston? I think a lot of people would be interested in seeing that.
Yeah, sure. My pleasure.
Absolutely. So, yeah, just a couple quick updates. The DeSci Boston Conference happened at MIT last week. It was a fantastic event where we had hundreds of people show up to talk and to learn about decentralized science. I was a part of organizing it, and the co-organizer from MIT said that this was one of the most engaged and enthusiastic conferences he had ever been a part of, and that he organizes one of these about every other week. So it was amazing. People were flying in from all over the world. People were staying for the entire time as well. Normally with these conferences, folks filter in and out for an hour for one specific session. So a lot of great discussion, a lot of great happenings, a couple new people who are interested in what's happening with DeSci Nodes, which is always fun. And we're looking forward to DeSci Boston 2023. So it'll be a great event. Thankfully, we were fairly fiscally conservative with this year's event. So we have enough of a piggy bank to run it back next year and hopefully do it even bigger and better. The focus of the conference was on demos. So people going up on stage and showing what they've built, showing applications, data, code, journal, pieces of research, whatever it may be. It was a kind of a focused demo day structure for the conference. And I think we'll be running that back next year. But one of the better received demos throughout the course of the day was actually what Chris ended up showcasing on DeSci Nodes. So he'll be showing that off in a little bit. We also had an ACM conference where Sina got the chance to sit up on a panel in front of a large group of brilliant blockchain researchers. Some great conversations came out of that. We're excited to see where that goes. This Thursday, we will be on a panel at SmartCon up in New York City. So excited to talk about decentralized science as well there. Then just a series of mishmashed other conferences around the world throughout the next month that we'll be at. So a lot of PR that can come from there. But with that being said, unless John or Carla or Philip, you have anything else to add, maybe conversation around the Future of Science seminar, go ahead and take a quick pause there in case you do.
Yeah, so we hosted the first Future of Science seminar on last Monday, and we will be posting the recording in just a bit, so feel free and check it out. We have opened a Slack channel because we want to keep the discussions that come out of it going after the seminars. So you can also, I will post everything. So there's a summary, a written summary, there's a video you can watch, and then you will get a link to the discussion Slack channel. So feel free to engage in all that, and then feel free to sign up for the next seminar as well. It should be, I think, October 17th or something.
All right, awesome. Well, we're excited to hear more about that. And with that being said, I see that Chris has now started to share his screen. So Chris, you want to just go ahead and take it away?
Sure. Attempting to share my screen here, but I can reiterate everything. So, I mean, it was a really fantastic event. The progress in the space and the amount of attention that it's gathering is increasing every single conference. So this is a very positive sign, because what we have to do at this point is make sure that the space is welcoming, that it attracts capital, that it attracts talent, and that people start building products that will become ultimately interoperable and provide alternatives and complements to the current existing system. So super exciting to see this, and I thank Eric and James again for organizing such a great conference. I am attempting to share my screen here. However, it is not working. So just give me a sec here. I'm going to test a few things here. Okay, I'm going to just go hop over to Eric's computer, and we're going to be sharing the screen from his computer.
Meanwhile, I'll sing and dance.
Thanks, John. If you could come on camera for the dancing part, that would be helpful.
Still don't have a camera.
We need to buy you a camera.
Yeah, I probably won't use it even if you get me one.
Okay.
I couldn't be in my refrigerator right now if I had a camera.
That's a fair point. That's a fair point. I actually just went and got some coffee. So yeah. It's still trying to come up, but I don't know if that's working. Maybe if Sina is on the call, he can potentially share his screen.
It might be Discord sucking.
Yeah.
Yeah.
You get just bandwidth issues as well. So Chris, if you want to pop over in here, we can try and share from my screen.
I'll do it from Sina's computer, so just give me 2 minutes to set up.
Okay, not a problem.
Is there recordings from that conference last week?
Yeah, so I'm working with MIT to try and get that. There's a little bit of bureaucracy anytime that you work with an individual group. But in the meantime, I can actually share my screen and just quickly talk about, so there is a recording that's available right now, actually. So if you go to DciBoston.com and click the watch the live stream link, and I'll just go ahead and put the main room stream in here. You can see the entire 6 to 8 hour conference. You can watch through it and skip as you please. I guess it's 5 hours of recording. It's not been cleaned, so there's still a little bit more work to do there. But just for the moment, it's a good place to just go and look.
Yeah, I see. DeSci Boston. Watch the live stream, right?
Yeah, and it would be the main room stream once you get to the link tree. For anyone else who's curious, I've also posted the link in chat.
Does anyone else have questions about DSci Boston?
Okay, there we go.
0x, could you mute or turn off
Can everyone hear me well?
your mic real quick? Thank you. Yeah, you're great.
Test. Test.
You exist.
Yep, that works.
I don't think he can hear us.
He can hear me, that's for sure.
I can hear you. Can you hear me?
Yes, we can.
Oh, great. All right, so let's go over this. So yeah, so we presented a demo of the latest iteration of DeSci Nodes, and we have a couple of interesting new features and things to show you guys. So I'm going to go ahead straight up. Can you see my screen?
Yep, crystal clear.
Okay, great. So, you're on these typical types of pages. Where do you want to go? Well, researchers want to typically go to the PDF. Here you have a paper. This is a paper about the history of ultramarine blue, which was the most precious pigment through the Renaissance era. This paper is quite special because the authors made it fully reproducible and added quite valuable artifacts that are typically not very well recognized in the current system. So what you have here is essentially a click-to-access link, which leads to the permanent identifier that is resolved by our service, which we called for now DeSci. And that essentially allows us to pull off all the data from the chain, to read the root hash, and to collect all of the connected components in IPFS, and to produce what we call permanent identifiers for linked data to address any single component. So the first thing we did is we started integrating with generative art systems. So in this particular case, it's Midjourney, but there's other very interesting generative models such as Stable Diffusion. And the idea here is that we can actually improve the way scientists communicate their work and beautify it by using generative art models to essentially produce cover art for these research objects. So in that specific case, we used Midjourney, but there's going to be extraordinary opportunities appearing with the new models coming out to essentially really enrich the visual communication that is produced around science. So this is something we're very excited about and that we've had great feedback from scientists. So you're in DeSci Nodes, you essentially have this mysterious icon on the side where you can interact with all of this richness, all of these finer features, look at all of the different components. So in that case, the author has a research report, a reproducible notebook, supplementary material, and data. So we can actually go over each of these and essentially inspect them and interact with these objects that have been posted. So for instance, the authors have posted here their data. So all the raw and processed data with the opportunity that we give them to easily verify their research outputs to be able to create more findable and reusable artifacts. We have the ability to connect reproducible notebooks as well. So in that case, we have a notebook which is essentially using an integration of VS Code, and we can interact with that notebook directly into the article itself. One of the things that we've been working around is essentially allowing researchers to easily, not only produce annotations, but also be able to connect their code, to connect their data directly in their research outputs without having to radically change the workflow that they go through, right? So this has been something which is very important for us. We don't want to add more work to authors if we can prevent that, and rather we prefer to work with a system that's already been workflows and habits that are already widely adopted. Another part which we're really excited about is this whole concept of collaborating with various organizations such as the ACM, the Open Science Foundation, the Gopher Foundation. So the ACM made these badges that are here to track that the artifacts have been shared, that they're reusable, that there are a certain quality of artifacts. There's also a new organization that we're collaborating with, which is called the Gopher Foundation. And the Gopher Foundation is there to create standards and systems and workflows and to essentially promote the use of this fair data principle framework and allow scientists to easily navigate it. So this is one of our major focus, is essentially how do we simplify the workflow for scientists to verify their research outputs. So here you can see that we allow them to add these metadatas. We have the possibilities to connect ontologies. The FAIR indicator is there in a way that can be verified by society. So you could imagine, hey, I want to have these attributes verified. Let's say you're a funder or an impact funder, research organization, you might want to have the possibility, well, you do want to have the possibility to verify that indeed these FAIR principles are respected. So you can hear, this I think you've seen in the previous demo, you'd have the possibility to add validation grants to these systems. We have also a full on-chain back-to-end end-to-end integration here that you can see. We're on early testnet right now. We're running optimism, which means that we can actually get the costs of on-chain commits and modifications following the Git workflow quite low, down to about 80 cents or 20 cents, depending on the amount of data that is being changed. And of course, another part is about the automated metadata generation. So this is something we're particularly, something that we're focused on, is to simplify the process of generating metadata for authors. There's different ways to do this. One of the ways that's particularly promising, in our opinion, is to use systems to essentially use machine learning solutions to take as input a PDF or a document, to scrap the data that's on there, and to use models to be essentially capable of generating metadata that verifies the data, which means that it will reduce the workload and reduce the cognitive load on authors, which is something that we're very focused on. So yeah, so this is a bit the state of the system right now, and yeah, very excited to see where this comes. We do have live code. I don't know if it's enabled on this particular computer. Let me test. Let's see if we can get this to work. No, it's not enabled on this particular computer. I think we might be in the view-only mode. But this is something that we've been working on, is essentially the ability to run these reproducible notebook directly inline into these manuscripts, into these research objects, to essentially impress funding organization and impress other scientists, so that these types of norms of creating reproducible research is something that can be scaled up and essentially adopted by a wider community. And the key for this is to make it recognized, is to make it something that is legible, and to have markers that are trustable, that the work is truly reproducible. So yeah, so this is a little update on our system so far, and I'm looking forward to hearing your feedback.
Well, Chris, one thing that I would be interested to hear more about is the feedback, both in the conference and from the user sessions that we had around this. So I know that we had an hour-long user session right after our presentation itself, and had a lot of great people come out to ask questions and to try out DeSci Nodes itself. So would be really interested to hear more about those conversations, what you kind of learned, and what people found valuable from the larger system.
Yeah, I think one of the interesting things about this conference is that we do have a wide variety of attendees with different backgrounds. So we were both talking to people that are scientists and people that are also non-scientists, and they often come in with very different perspective. From the scientist side, the thing that's the most interesting to many scientists we've been encountering and talking to is the possibility, well, there's two angles to this. One of them is the possibility to get credit for going above and beyond the call of duty, meaning that you make your work reproducible, you share research artifacts, and there's a method for this process to be recognized so that it counts. And I think this is something which is sorely lacking in the current system of funder to scientist relationship. Another angle is around communication, right? Communication of science, about reaching a broader public, about essentially casting a wider net. And in that context, we discussed things like video abstracts, like alternative means of science communication, because it seems that essentially the information flow right now is you go on a preprint platform, you look at a title, if it sounds like something interesting to you, you read the abstract, and if the abstract is interesting, then you dive into the manuscript, right? So this is the current workflow. And when you think about it, we could have an intermediary layer, which is essentially, hey, here's a simplified abstract, a layman's abstract. And then you might have a video, right? A video like a short 10 minutes, 2 minutes video. There's this great channel out there called 2 Minute Abstracts on YouTube, which has done great deal of outreach for science in general. And these are the types of mediums that we're thinking of incorporating, so that scientists, when they create a research node, they can essentially add a video abstract or a conference presentation that they gave, and this could act as like a way to explain the research, a way to get your colleagues interested, and a way to consume the research that is not yet hasn't been solidified or practiced at scale in any form of academic societies or modes of publications. So this is really from the scientist side. From the non-scientist side, or let's say the students, the people that we had the chance to talk with, well, there's a lot of interest in this idea of opening up science more broadly, to have more citizen science involvement, to be able to form communities around science. And I think this is something that has a broad appeal, and something we also want to facilitate with this idea of having people as node stewards that would go out there, find extraordinary research objects that cannot be stored because of data limitations or other forms of limitations that we're not beholden to, and create these great research objects that are impressive, that gather credit to their authors. So yeah, so these are the kind of angles and feedbacks we've been having. A lot of the conversations, though, have been focused about integrating with other DeSci projects. So there's people working on discourse graph. So discourse graphs are a mode of communicating ideas, hypotheses, counter arguments. There's people working on tech trees, or research road mapping. There's essentially a vast effort out there in general to start thinking about interoperability early, right? So you could, for example, have a research roadmap, or let's say a tech tree that links to a research roadmap, that links to a Discord graph, that links to a DeSci node, right? So that would be the type of interoperability we're talking about. I'm happy to take questions, talk a little bit more about DeSci Boston's and some of the things that happened there, or just dive more deeply into the products we're developing. I could add to this that there's really one pain point that we're so far becoming more acutely aware of. It's a problem of storing large data sets at scale in an economically efficient way. And this is where decentralized storage solutions can really come in to break down the costs of long-term archival, long-term storage, right? Storing a petabyte on AWS S3 with some degree of usage is going to cost you $500,000 a year, right? Which is, of course, not something that can be practiced at scale. And when you look at the OSTP memo, which is the White House memo mandating open access by 2026 for all publicly funded research, as well as its mandate around open data, it's clear that there's going to be an incredible demand for storage and availability. So essentially, we need solutions that can scale better in terms of cost for storing large amounts of open scientific data. And this is where these crypto economic networks can come in, because they've been democratizing the costs of data storage. So for instance, IPFS, Filecoin, these types of solutions out there provide great alternatives for storing large data set at a fraction of the cost. Other systems such as Arweave that really focus for long-term, quote-unquote, permanent storage for smaller files, which also, could have tremendous value when it comes to permanently storing scientific metadata, right? So there's also this idea that we want redundancy in storage solutions, that different sizes of files can use different protocols, different systems to provide redundancy in the system.
So, Chris, it was also really interesting to see the breadth of projects who were at DeSci Boston, because it really did go across a much larger spectrum. We had the scientific societies, we had people building out application and tooling, we had quite a few projects focused on base infrastructure. I think one of the ones that I personally found more interesting was Bakoyao, and just the general concept of compute over data. For anyone who's in the call that may not be familiar with it, would you mind explaining a little bit more about Bakoyao, IPFS, compute over data, and how
happily.
these backend protocols can help?
Yeah, no, this is a super interesting effort from Protocol Labs. So Protocol Labs is working on decentralizing the internet, the entire internet stack. So it's not just storage, it's also compute. And Bacalhau is essentially a code name for a project which involves co-locating compute with storage. So imagine, rather than having only storage providers, right, you also have compute providers that co-locate the compute with the storage. And what that means is you could have essentially an open and free market on computation, which could drastically cut the costs around compute, around running all of these operations. But that's not all. So when you think of a database, an open database, open state database, where you have every piece of scientific data is hashed and is represented as a tree. You would have the ability to conduct operations, compute operations directly from these hashes, these CIDs that would essentially link directly to the data that can be operated upon. And every operation on that data would essentially add to the current, would add, like the compute step would then be, for example, you take a satellite images and you might want to grayscale them, and the grayscaling operation itself would generate metadata and generate a data set that others could then find. So you wouldn't need to repeat the same compute operation. And so this is the idea around Bacalhau. And it's still an experimental project. It's at the very early stage and it's extremely ambitious. And this is one of the things we're going to be working towards, is running these executable notebooks, these containers, the code, and DeSci nodes using that co-located compute and data storage solution on these decentralized networks. And our ambitions in the long term is that not only does it drastically cut the costs of these operations, because I mean, let's be real, Amazon and Azure and other cloud service providers, they overcharge for a lot of this, right? So they have certain business models and business practice and sets of incentives which are not ideal when it comes to the perpetuation and using knowledge at scale. So this is the idea with Bacalhau.
How to spell that again?
Bacalhau, like the Portuguese dish. So the whole idea came up in Portugal, and the first code name of the project was COD. So compute over data, and a cod in Portuguese, essentially a cod dish. Bacalhau is a famous cod dish, and so that's how the name came about. In the long run, of course, I mean it could morph into IPCS, right, interplanetary file compute system. So that would be possible. Right now, it's called Bacalhau.
So is there like a site for this so I can see like their code base or their vision for this?
Oh yeah. Let me just link that in the chat.
So Chris, I've already posted it. And John, if you have kind of the larger overarching link for a couple of the different compute over data projects, that might be interesting to post as well. So I think Bacalhau is, sorry, go for it.
So what Protocol Labs is putting together is something called the Compute Over Data Working Group. It's cod.cloud. And if you go there, there's several, are we up to a dozen? There's about a dozen projects working on some form of compute over data or file storage together because, like Chris said, it's a very ambitious project. Jeez, happy Monday. And so it's more than likely that one of these will fail or all of them will fail, and the people from them and the lessons they learn will go and build something else. So there's an idea of a working group where all the projects are supporting each other just to try and get what Chris was just describing into reality, which is much lower costs, not run by AWS or controlled by Amazon by any means necessary. We just want someone to succeed at it at this point.
So Chris,
COD.cloud.
Yeah, Chris, would you be able to talk to us a little bit more about the current workflow of a scientist working with some of these large data objects? What does their life look like?
Well, first of all, the first problem is sharing these large data objects. So a lot of these data sets that might have very, very broad interest in communities end up being available upon request. And what tends to happen in these cases is that the data is sitting somewhere in a university on a couple of hard drives, and it's essentially a tremendous friction for the researcher that might have published, his work 2-3 years ago to go back, get the data, make it available. You end up sending hard drives by FedEx and all of these kinds of things, right? So that's the first big friction point, is that there's data out there that's tremendously interesting and high value for scientific communities, for which there's no viable and scalable long-term storage solution that allow their colleagues to interact with that data. And that means that that point of friction right there is essentially costing us a lot as a society, because if scientists were able to access these large data sets at scale, not only would we progress in terms of reusing these artifacts, but we would also create systems to reward the scientists that share these data sets in a way that they can accrue credit more easily. And the net effect of that is that you can have a flywheel where now more scientists are sharing their big data sets, and this is creating incentives for others to join the bandwagon. And in the long term, of course, this would be tremendously valuable for accelerating knowledge. And this is something, by the way, that funders are going to become very, very interested in, right? The ability to track alternative metrics to citations. Because right now, essentially, a funder is a little bit blindsided by the available analytics that they can receive. And you could think that given the emphasis around interoperability and open data that is now being adopted very, very widely, both in America and the European Union, there would be tremendous value for a funder, for a research organization, for an impact-minded organizations to essentially be able to track, what's the data reuse of that open data set, what is the new original research that came out of it. These would be metrics that could consistently and significantly enrich the way funders look at their impacts, and which would trickle back down to the way science is practiced today.
It blows my mind that someone would need to FedEx a hard drive to be able to send a terabyte of data. It really and truly feels like we should be beyond that at this point. I mean, that is such an unreal pain point to have. There's so much potential there. Yeah, wow. Okay. So
yes, and I think one of the big goals is just going to be demonstrating that, yeah, you have 500 terabytes. Well, we can store it in a DeSci node. And I think that's a tremendously valuable proof of concept to just show that, well, there are now systems that have the capability to scale to large data sets and make these data sets available directly in research objects.
Well, you think about the number of papers that can come out of a large, well-formatted, organized, documented, and widely shared data sets. I mean, one data set can easily spawn dozens of papers, if not hundreds, or even potentially more.
Oh yeah, and we've seen this with and in general, this is an issue in many fields of science, is that scientists focus too much on collecting data and running new experiments, rather than having organizations or groups of scientists that come together to gather extremely large amounts of data on a specific question that gives them a much higher level of statistical power and allows them to really peer deeply into the processes, right? So I can tell you this from the perspective of a neuroscientist. We would be much more advanced and ahead as a field if we were able to work with extremely large data sets as a community to understand very basic processes and their interactions and how this is orchestrated in the brain. And the alternative to this, the current system, is like every research group and research lab tends to go on and collect, small scale data, which doesn't give you nearly anywhere the robustness and the ability to peer and understand processes that large data sets can give you. And one of the big issues is that this links into the whole replication crisis, because small data sets are not worthy for giving you false positives. And these problems are systemic. And if we can create systems to store large data sets, to incentivize the creations of large data sets, so that funders can recognize these efforts and fund more such efforts and return credit to scientists, then we could really kick off a flywheel effect of reusability of valuable artifacts. And that would have a downstream effect on creating more reproducible and replicable science as well.
So, Philip, I see where you're on the call at the moment, and this conversation kind of brings to mind a story that you've told me in the past around having to work with a larger community on collecting a massive data set for genetics and some of the challenges that went into that early in your career. Would you be able to come off mute and maybe tell us a little bit more about your experience shepherding a community to create data sets like this?
Back in the days when we started.
I see where your voice is lit up, but we can't hear you at the moment. At least I can't.
It's coming through. It's just really quiet.
Okay.
Okay. Let me see if I can fix that.
No better at the moment.
No.
He said he'll see if he can fix it.
Yeah, I mean, I can give a secondhand account of that story. It's always better to hear it firsthand, though. But yeah, I mean, the genetics community, especially the intersections with complex behaviors, has had its own problems, right? They were running studies on data sets that were far too small, looking for candidate genes and looking, for the gene of depression, for the gene of X, the gene of ambition, and all these things. And these studies ended up essentially becoming giant noise mining operations that just don't replicate, because in order to capture signal at scale, you need tremendously large data sets, since the effect size of specific genes and combinations of genes is so tiny, and the measurements of human behavior are noteworthy to be noisy as well. So for those efforts to pan out, what was really necessary was organizations to go out there and collect tremendously large data sets, the consortiums to form, to combine different data sets from different organizations, from different nationalities, and to essentially enter this relentless quest for more and more and more statistical power that allowed detecting more subtle effects along the road, right? So this has been a quite a wide transformation into this field, which is very heartening to see, and I wish other fields of science would follow a similar path as well. I hope, Philip, I did justice to to these stories, but yeah.
Can I ask to clarify the data format that you are driving at? You started this presentation with saying that, okay, we can sort of embed the code together into your paper. So how is that organized from a data perspective?
Yeah, that's a great question. So there's different things to this. So, I mean, we can take any kind of arbitrary data formats. When it comes to the data model itself, there's a data model that's called JSON LD. It's JSON for linked data. It was essentially an offshoot of the semantic web efforts, and it has the advantage of being self-contained and self-describing. So let's say you're a machine and you want to query a DeSci node. You can query the PID of the node, add a specific appendix to it, and return the raw JSON LD object, which would give you context on what things are, right? Because it's using controlled vocabularies and terms that are drawn from ontologies and taxonomies, right? So you'd be able to understand, oh, this is data. This is the data that belongs to this paper. This is the code that belongs to this paper. This data is about, geology modeling of geological modeling of glaciers, right? And you have those ontologies that are referenced directly within the JSON LD data model that essentially allows a machine to be given context as to what these data objects, these linked data objects represent, right? So that's the JSON LD part. Another part to this is what's called IPLD. IPLD is a data model for IPFS. It's essentially, think of IPFS not as a sea of, let's say, like a soup of disconnected data pieces, but you could think about it as a forest, right? And so IPLD uses this concept of a Merkle DAG, where you have pieces of data that reference other pieces of data by using content identifiers, so CIDs. The advantage of CIDs over regular vanilla links that JSON LD would be using is that they don't suffer from link rot. So they don't suffer from content drift, specifically content drift. Since you take the object and you hash it in a cryptographic function, and you take the resulting string, and this is essentially your content identifier, and this is what is nested in this IPLD data model.
I see. So basically, you're saying that instead of traditional paper, we sort of split it into this smaller data pieces that become addressable. Is my understanding correct?
Yeah. So essentially, it's this concept of a research object, right? So currently, if you look at how research artifacts are disseminated, you might have your paper on bioRxiv. You might have a code repository on GitHub. You might have a video of a presentation, a talk you gave on YouTube, or somewhere buried in a conference page. You might have a slide deck on your website. You might have all sorts of different resources that are scattered and they're disconnected as a result. And this is a tragedy for the integrity of the scientific record. And it's also a consequence of how the incentives are set up. So scientific publishers have absolutely no business model at all for anything beyond PDFs, right? So this is their business model. That means they don't want to be responsible for the other pieces. And they do pay lip service to the idea of connecting these artifacts, and they tend to do this on their websites. The good ones will do that. It remains a brittle connection. The ideal form of connection is essentially a place where you have a secure data structure that allows you to connect all of these artifacts in a way that is protected from content drift. And that's what we're implementing here. So you could think of your research paper not as a single PDF floating on a preprint platform or publisher website that might have links on the publisher website to additional resources, but you can think about it as a cohesive unit that contains all of the supplementary artifacts in a linked data model that is immutable, that is secure, and that is immune to content drift.
What about importing the existing data sets like by archive into this model?
Yeah, so that's a bit tricky because preprint platforms have certain policies. And one of them is that the default licensing agreement, I believe it is still the default, is not Creative Commons, but it's something that says, hey, you give the right to the preprint platform to display your work. So that means there's not, let's say, the majority of preprints on archive and other websites have that restrictive license agreement, which means it's not possible for us to directly pull all of that data into our system. That doesn't mean that no data can be pulled. There's still quite a bit of work with Creative Commons licenses that could be scrapped, or we could combine the supplemented artifacts into cohesive data objects that could be stored into these decentralized storage solutions that we're creating.
Yeah, that would be great. That would really onboard many people immediately to your system, because it would help if they see their submitted publications, how they look like in this more advanced data format. People would love it.
Yeah. I mean, we're really hoping so. So one of our goals is just to make scientists proud. We want to make them more proud of going beyond the call of duty, because there's many scientists out there that strive to create reproducible work, that strive to share their artifacts, that just go beyond what is recognized by the current environment, and they don't really have a lot to show for it, right? And I think that's a really big problem in terms of incentives. And if we can create a way for them to be proud and to create a trusted relationship with their funding agencies, that they could recognize that these funding agencies would then recognize that these artifacts are being shared and that they're valuable and that they're being reused by the community, that could trickle down into a flywheel effect that could really have a profound effect on shaping the incentives in science.
It would be also great if we can integrate it with traditional libraries, like just the usual books, and represent books in this format, just like ordinary textbooks. Of course, it's much harder project to do, because that data is really protected by copyright and all other sorts of things. And but I wonder, what's your perspective on this?
Yeah, my perspective on this is that the copyright landscape is changing rapidly. So Creative Commons licenses are gaining fast tractions along a lot of publishers and preprint platforms. And especially with the OSTP memo, the push in Europe for fair data principles and permissive licensing, that means, the ideal state is not one in which people create their moat and their network effects on their platform based on copyright, right? So that is not, let's say, a good way to create a moat in terms of promoting the greater good. The better way is to essentially compete on presenting that information, right? So if you think of a model in which all of the data lives in a soup or a forest of linked data trees, and now anyone can access those data trees and pull them into their interfaces and create a plurality of methods, models, services, interface to essentially be capable of interacting with that vast data pool. And that's the concept essentially that we're trying to push, which is, let's move away from silos that store data in closed formats with sometimes restrictive licenses, sometimes not, towards a model in which we have gateways that access a dataverse that is indexed on an open record, right? So that's really the model we're trying to push, and we've been building the foundations and putting some of the creating the initial systems to really test that out as a proof of concept.
Thank you for all of this, Chris. Does anyone else who's on the call right now have questions around the topics we're talking about? All right. Well, with that, I think we can assume that silence is golden. Is there anything else that we want to cover from, I guess, a catch up from DeSci Boston, from the ACM conference, from the presentation and updates for DeSci Nodes? I think we've got right around 10 minutes left.
Yeah, I think a lot of the question is like, where is value maximized? And I think that's a very important question for us also to solve. And the way we've been thinking about it is, if we can maximize value for impact organizations in a way that it allows them to create trusted alternative metrics to the current system, that could just be the best leverage point we have to shift the incentives. So we've been thinking long and hard about how to create examples and initial displays of what such a system could work like. So hopefully in a couple of maybe a month or two, we'll have some really interesting prototypes to show you guys.
And that's actually a great segue into the Node Stewards program. So I see where Carla just jumped off the call, but I can give a quick summary of exactly what we're looking for and how we can use help from the community in creating some of these examples. Or Chris, if you would rather give the, I guess, the view into that, that could work as well.
Yeah, more than happy to. So this is one of the things we've been considering is, hey, why don't we tap into our community to go out there into the wild of the World Wide Web and find these extraordinary research objects that are out there that provide clear value, but that are not displayed in the right way, that aren't constructed in the optimal way of either displaying, sharing, finding about the interoperability parameters, the fairness of the underlying data, and essentially take those examples of extraordinary research and just bring them to life into DeSci Nodes in a way that we could build like a gallery of examples and say, hey, this is what the future of science could look like. This is a system that would promote reusability, that could accelerate knowledge, and just start building towards this momentum and that base to essentially facilitate the onboarding of scientists, convince the world that the system actually brings value, that it actually allows people to be recognized for all of these great and important things that scientists do, like creating reproducible objects, like sharing their data, like creating these rich interactive documents. We can do this. We're building the tools to do it, and it's now going to be about finding the right people that are really passionate about science, that are also disheartened by the current system, and that believe in a more beautiful and more reproducible, more interoperable future for it, that could go out there and give us, hey, have you seen this? This is a really cool paper. This is a really cool research objects. Let's make it into a DeSci node. And we then build it together, test out the system, figure out, what we need to improve. And once we get to a stage where we feel, this is actually really good, we could then reach out, contact the scientist and ask them, we found your work. We're really impressed by it. We decided, to help you store the data, to help you verify your research outputs. Perhaps we even created fantastic generative art on it. Just reach out and get their consent to essentially post and put these research objects in the wild, and that could really create, a flywheel of people gaining interest and picking up on the beauty of systems that could really help secure and create more reproducible research.
Absolutely. So to anyone on the call who's interested in helping out with that, in finding and creating a beautiful example of open science, please feel free to reach out to either myself or John through GM or through DM, Jay Ringo, and we can help you kind of learn a little bit more around exactly what it is that could be done to help showcase open science and how you can contribute to that. It's a great opportunity, and there's a lot of interesting stuff that can come out of creating these nodes.
Can you guys hear me now?
Yes, we can.
Ah, wonderful. Okay. Yeah, so I just wanted to add to that. So the Nodes to a program will probably allow people to also just specialize in different things that they're particularly interested in. So one particular aspect of being a node steward could be to identify researchers that have produced really outstanding high quality research in their field that is actually already available in the open domain and which in principle could be used to generate a research object and to connect all the pieces. There could also be people that specialize in just, basically the software aspect of it, which would mean like understanding the code that they've posted, maybe annotating it a little bit further, connecting it to the data, actually enabling these reproducibility runs. There could be people that specialize in generating cover art for that research based on, Stable Diffusion or Midjourney or other programs. So there's various opportunities for people to actually get involved and to make a difference and to help us grow the system. And I'm actually quite excited about it. I think this can be really, really cool.
Yeah, I definitely agree on the specialization side. And I think everyone is going to have different affinities, and having the ability to say, hey, I'm really interested about the part of like illustrating science with these generative models. And I know quite a bit about prompting these AIs, and I can make some really cool stuff. Others might be more on the side of, hey, I actually know a bit about containers, and I can help connect the container. I can help connect the code. I can make this a living, reproducible object. So yeah, we're really excited to find people that have interests into these different fields, subfields, and sub parts of the job, and yeah, reach out.
Divine, I see where you just came off mute for a second. If you have something to add there, please feel free.
I actually server muted Divine because they have a hot mic, and then I checked it. Yeah. But I will unserver mute Divine. If you're here, feel free to go or mute yourself.
No, I have no question.
Okay. Thank you for muting yourself.
So yeah, maybe I can add something to this. So yeah, this initiative, this reproducible compute object, sounds really interesting to me from the point of view of the work that we have been doing here with constructing knowledge graphs from existing databases of scientific publications. So I really want to sort of explore the details of the data format that you guys are producing and seeing how we can integrate that into our models.
Yeah, very cool. I mean, love to talk about it. I think it's also an awesome time to start thinking of interoperability between different projects and seeing how everyone, can add value to an alternative ecosystem that could complement all the blind spots of the current system.
Yeah, so I will be happy to. So I will be happy to talk in more detail on more technical side of it. Perhaps later on after this meeting, sometime later.
Yeah, sure.
So yeah, we have, I think the Node Stewards program is a great way to learn more about the technical details and to actually get the chance to interface with the product itself. We have coffee chat that starts up right after this in about 4 minutes. So feel free to stay on. We can discuss that a little bit further. I think there's definitely a lot of overlap between what you're thinking of with search and some of the knowledge graphs and what we're building with DeSci Nodes. So the chance to interact with the product early on could be a great way to learn more. And with that being said, I think we're pretty much at the end of our allocated time for today's community call. So just wanted to quickly say thank you everyone for joining. Please feel free to stay in this channel for Coffee House afterwards, which is a more informal discussion, a little bit more open forum where if you have questions, if you have topics, either related to DeSci Nodes, decentralized science, Web3, or just life in general, you can come in and discuss. It's normally a very interesting conversation. So to anyone who's here, we look forward to seeing you there. And yeah, thanks everyone for joining today.